Hey Mary, this is Miss Tracy. So let's look at these problems that you need help with. So here's the first one that you asked about. We've got 3x plus 7 over negative x minus 4 plus x minus 7 over x plus 4. So we know we can't have a negative denominator. And when we have this negative, that's a negative denominator. We don't want to have that. So we want to factor that out. So then that's going to look like 3x plus 7 over negative 1 times x plus 4, right? And then this stays the same. So what we're going to do to get rid of this is just multiply this first fraction times negative 1 over negative 1. So then what we end up with is negative 3x minus 7 over x plus 4 plus x minus 7 over x plus 4. So now that we have the same denominator, we can just squish everything together. And since this is a positive sign, it doesn't change any of the signs in here. So we can just draw this line together. And then we can combine like terms. So we have a negative 3x and a positive 1x. So it gives us a negative 2x. And then we have a negative 7 and a negative 7. That's a negative 14. So then we put that over x plus 4, and that's our final solution. So this would go in the top blank, and this would go in the bottom blank. And that would be how we would solve the adding of these two together. All right, let's look at the next one. All right, here's the second problem. We have to find A, B, and C. And we have that two triangles that were on top of each other. So I separated them out so that I could see them better. And we're going to call this one the left triangle, and then we have the right triangle. Okay, so let's see. We're going to set up, first of all, we're going to use Pythagoras theorem to find A. So 4 squared plus 5 squared is equal to a squared. So that's going to be 16 plus 25 is equal to a squared. That's going to be 41 is equal to a squared. We unsquare. So the square root of 41 is equal to a, and it's a positive because we're talking about a length, and length is always a positive number. So a is equal to the square root of 41. That is your answer. Okay, so now that we know what a is, we can use that to either solve by scale factor or to solve by proportion. I think what I'm going to do is use scale factor. So I'm going to use the left to right. So the left triangle times some scale factor is going to be equal to the dimension on the right triangle. So we're going to start with the two numbers that we actually have to compare. So 4 times some number is equal to 7. When I divide both sides by 4, the scale factor is 7 over 4. So I can use that to multiply using this formula for every other dimension that we have. Okay, so let's do 5 and C. So 5 is the dimension. Remember, this is our calculation, L, and our scale factor is 7 over 4. So we can sub that in. L times 7 over 4 is equal to R. The left triangle times the scale factor is equal to the right triangle. So on the left, we have the 5, the upright. So 5 times the scale factor of 7 over 4 is equal to the, actually, the right dimension would be C. That's what this side is right here. So 5 times 7, that's going to be 35 over 4 is equal to C. That's it. That's our answer. 35. Oh, I keep hitting the wrong thing. I'm too close to the top is what it is. Let me scroll that down a little bit, and I'll rewrite that. So 35 over 4, that is the answer. Okay, so now we just need to find B. And we already have the value for a, so we can use scale factor of square root of 41 times scale factor 7/4 is equal to square root of 41 plus b. All right, so for square root of 41 times 7 is going to be 7 times the square root of 41 over 4 is equal to square root of 41 plus b. To get b by itself, we're going to subtract square root of 41 from both sides. All right, so the only problem is we have got to make that have a common denominator of 4. So we would multiply that times 4/4. So that would be 4, negative 4 times square root of 41 over 4. So this would cancel, right? We did this to get here. So now we subtract 7 minus 4, that's going to be 3, times the square root of 41 over 4 is the value of b. That is our answer. That's it. 3 times the square root of 41 over 4. Those are your solutions. All right, let's look at the next problem. All right, so we've got to find b, c, and m. So if this is 120, then this has to be 60, so b is 60. So we found that already. B is equal to 60 degrees, and that means if b is 60, then c has got to be 30 degrees, right? So we figured that out. So now what we need to do is find m. We are not given the hypotenuse length, so we cannot use the 60 degree because we don't have this and we don't have this. But we can use b because we do have 10, which is the adjacent side, and we have m, so that means we still don't have the hypotenuse, so it means we need to use tangent, right? So in SOHCAHTOA, that's the one that uses the two sides and not the hypotenuse. So we're going to use the tan of b, and b is 60 degrees. So the tangent of 60 degrees is equal to, and that's opposite, so m is the opposite over the adjacent, and the adjacent is 10. So we know that we can't perform this calculation. We're going to get rid of the denominator, so multiply both sides by 10. So 10 times the tangent of 60 degrees is equal to the value of m, because these two would cancel. So now we just have to perform that calculation on the calculator. So we pull this up and we say 60 tan times 10. That's going to be 17.32. So 17.32 is the value of m. That's what we have. Alrighty, so that's how you would solve that. You're going to use your equation here, the formula, and remember the opposite is the one that it looks at, and the adjacent is the side that makes it up. And b was equal to 60, so that's the tangent we used. Okay, so m is equal to 17.32. All right, let's look at the last one, I do believe. All right, so this one tells us that we need to find side m. That's what we're looking for, is the dimension of m. And we'll probably have to find p along the way to get there, but let's just figure that out as we go. Let me switch to red so that you can tell what's new. So this is going to be a straight angle. If this is 150, then this is 30, right? If this is 30, we know this one is going to be congruent to this one, so that one is 30. So if this is 30 degrees, this is 60 degrees, right? Because this is a 90-degree angle. All right, so now that we have our degrees of measure, we can start to figure some things out. We need to find m, and we need to find, we don't really need to find p. So let's look and see. Let's look at so, ka, toa, and see which elements we have where we can solve something. We have all the degrees of measure. So all we really need to do is figure out, we need to find the hypotenuse. So that means we can't use this one because it doesn't have the hypotenuse in it. So it's going to be one of these two. So we don't have P and we don't have M. So that means we can't use 60 degrees because we have to have one of them known. Right? So that means we're going to use the adjacent side and the hypotenuse. This is the adjacent and this is the hypotenuse. So that means adjacent hypotenuse, that's these two. So we're going to use the cosine. So the cosine of 30 degrees, that means we're using this angle right here, is equal to the adjacent, which is 2, over the hypotenuse, which is m. Well, no, we can't perform that calculation. We can't divide 2 by some unknown number. We're trying to find the unknown number. So we're going to multiply by m on both sides. This would cancel. And so now we're going to, I'm going to make this a little bit smaller so it's easier to write with. It doesn't slash so much. Now we've got m times the cosine of 30 degrees is equal to 2. Well, we can't solve that either. We've got a factor and a factor. So what we're going to do is divide by the factor we know, cosine of 30 degrees, on both sides. These would cancel. So now m is going to be equal to 2 divided by the cosine of 30 degrees. We can perform that calculation because those are both two known values. So m is going to be equal to, and we're going to pull up our calculator to find out what. So we've got 2 divided by, and in parentheses, I'm going to do 30 cosine, and then equals. That's going to be 2.31 because you round this 9 up. So 2.31 is the length of m. And that's how we find that. All right, so it's all about being able to find your degrees of measure or find the which sides you need to use to get there. This problem was all about realizing that we couldn't use two unknowns to solve anything. We had to use this base in the calculation and figuring out which side it was. And in this case, it was the adjacent side with the hypotenuse, which led us to use cosine because those are the two sides we use in that formula. Those are the things you need to look for when you're solving these types of problems, the parts that you have so that you can determine the formula to use. All right, I hope that helps you see that a little bit better. If you have any more questions, I think that was your last one. Let me double check. Yes, that was the last one. So if you have any other questions, please feel free to ask. All the pods will stay open until the end of December. So you have a couple more weeks to work on these. And good job for keeping up and persevering. Again, if you have anything you need, let us know. Me or Miss Anna, either one, will be happy to help you out and get you to where you understand what's going on. All right, talk to you later. Have a great Christmas. Bye for now.